Let us introduce the next video. This explains the repairs of concrete cracks. Cracking is inevitable for reinforced concrete structures. As years pass, the number of cracks will increase, or at least, never decrease. If you neglect to repair them, the conditions could be unexpectedly worsened. As rainwater, gases, etc., enter inside the structure, reinforcement in it will rust up. Such rust will develop expansion pressures to rupture the concrete frames. In time, the building could sustain serious damage. In order to maintain the stability of a concrete building, proper maintenance is indispensable. Will you please imagine an ice cube? If you pick it with an ice pick or something else, giving pressure until it cracks, the cube will crack. In other words, it has been cut up. The concrete cracks are the same as for this ice cube crack. A slim line is not just a line, but an outside section line, only seen from the outside. This is what really happens. Taking the fact as it is, it can be said that the cracked wall is a very crucial condition. Now we will introduce Shika's application method of SK grout plug A. This grout plug method is a right strengthening and repairing approach to tackle such a problematic crack in a square way. This is a Japanese construction technique recognized worldwide. Now, let us explain the procedures step by step through the video pictures. This example is the repair of cracks developed in walls of a warehouse. Here, we employ such an injection method as will not largely spoil the appearance after the repair work. In the case of SK grout plug A, attach a temporary seal around the crack, and then fill the inside of the crack with the resin by using the plug exclusively developed for this purpose. In such a case, pay attention to the fact that the seal, if directly attached, is likely to smear the wall surface, in particular if it is exposed concrete. First of all, prepare the wall surface to make the smeared stain less unsightly. Apply a kind of protective membrane on the wall. This membrane will help the wall become less smeared by the seal and make the seal imprint less unsightly. Such a protective membrane is the Grout Pak 439. This Grout Pak 439 is loosely segregated as seen in this sack. Prior to use, rub the ingredients together from outside the sack to produce a uniform mix. Now make a test to select a proper concentration of Grout Pak 439. First, prepare trial application frames for undiluted liquid, 50% dilution with water, and non-application spot of Grout Pak 439, all on the wall surface. Next, apply the undiluted Grout Pak 439 and 50% diluted 439 onto the prepared test frames. This is fully dried up Grout Pak 439. Then apply a test seal by using Grout Pak 1. This is the test frames cured to next day morning. Check the smear of the imprint on the wall, as well as the adhesion or peelability of the seal. Well, at the undiluted 439 application frame. The seal can be easily peeled off, and the imprint has been little smeared, even with the 50% dilution. You can see slight smears. The seal also seems, more or less, hard to peel off. Well, for the non-application frame, like this, considerably hard to peel off. The worker is removing it with both hands. On the wall, you can look at the clear smears of the seal. It is clinging fast. As can be seen, the peelability of the seal and the condition of smear are largely dependent on the concentrations of Grout Pak 439. As the result of seal testing, it can be said that the undiluted 439 is best for this type of wall. These procedures show the way of selecting the most practicable method. Now, let's proceed to the actual injection procedures. The tools and materials we use here are as you can see in the picture. First of all, start preparatory cleaning of the substrate along the cracks. Remove dust and other foreign substances with a dust brush to make a clean surface surrounding the cracks. Then, coat Grout Pak 439 as a pre-treatment. By using a brush, apply the mix coat along the cracks. The coat should be 50 to 100 millimeters wide, centered on the crack, and be finished to a uniform surface. Also, there comes hardness check of temporary seal in a later part of the processes. We have to reserve a space for that process beforehand. We had better record this space as test seal so as to be easily identifiable. Next, check the width of a crack with a crack scale or other appropriate tool, recording a memo on the wall. This memo is required to provide against a case where the crack is to be covered by the temporary seal and becomes not visually identifiable in the later processes. Also, the crack width in this memo will give the guidance for injection of resin. The next process is to provide a marking with which an injection plug is fixed. Before it, we had better know how the resin would be filled inside a crack. This is an actual working scene. Like this, the resin would extend in a semicircular pattern from the injection port of the plug. It will enter the crack gradually upward and downward, and toward the deepest point inch by inch. By keeping the timing with the extension of resin inside a crack, provide a first mark at approximately 125 millimeters from the tip of a crack. Then, provide additional marks at intervals of 250 millimeters or so. After the completion of marks, apply the temporary seal. Get Grout Pak 1 ready for use and cut the tip of a nozzle at an angle of 45 degrees. This arrangement is, like the present job site, effective on a flat surface of substrate. It is really skilled workers' wisdom in that it enables sealing and spatula pressing to be made simultaneously. Set Grout Pak 1 onto a cartridge gun, like this. Seal a crack with Grout Pak 1. The seal should be worked out, adjusting its width and thickness to the advantage of the nozzle tip angle cut in the previous scene. At a marking spot, shape the seal in a circle of 2 centimeters in diameter. Like this, by keeping the seal 2 to 3 millimeters thick, the seal becomes harder to tear off in removing operation. Contrarily, if we keep it thinner, it will become difficult to peel it off. Be careful of that. Get grout pack A ready for use. At the beginning, produce the setting seat out of the box of grout plug A. Succeeding to the seal application, promptly press the setting seat for grout plug A. When the temporary seal has dried up, it would be hard to fix the plug, so promptly set out the pressing work. The 4 holes provided in the setting seat are to instantaneously check whether the plugs have been properly fastened, and they act as anchors after the hardening of the seals. Thus, they are a real job facilitator. In the pressing of the seat, make sure that the seal materials leak out at every hole. Lastly, we have to do the test sealing to check the hardening of the temporary seal. Let's provide the test seal in this manner at the frames, which have been marked as test seal. Next day, check up the test seal. If it has hardened firmly, it can be said that the temporary seal also has hardened likewise. Never fail to confirm whether it has hardened and whether there remains any void or split in the seal. This is an important process to prevent the injected resin from leaking out. Set a pressure tank to the previously bonded setting seat. In this setting, make sure to keep a Sika mark front. Next, measure and agitate the epoxy resin for injection. First, agitate the epoxy resin of super low viscosity or low viscosity in the standard mixing ratio. Agitate the resin with a spatula or other appropriate tool to make an evenly mixed resin. Now we do the advance injection of Everbond EP400 with a SK Pump 4. While pressing the back lever of SK Pump 4, insert a front cap into the resin mixture and gradually pull the piston rod to suck the mixture into the pump. After that, start the injection through the plug already set. For vertical cracks, start the injection with a plug provided at the lowest point. The recommended scale reading of the pressure tank should be 0.5 or so. Lightly press the SK pump to the plug's injection port and inject it with 5 to 7 strokes. When grout plug A enters this SK pump, the air inside the tank is to be pressurized to force the resin to automatically extend into a crack at a low pressure and low speed. That pressurized function is automatic. If there is a so-called penetrated crack, which is cracked through the entire depth, and its rear side cannot be completely sealed, then resin of low viscosity will flow down to the bottom of the crack and run out of the rear void. Everbond EP400 is a resin of super low viscosity, and the pressure tank is soon emptied at a large crack. Therefore, the resin's viscosity needs to be gradually increased until after the resin will not have been flowing down inside the crack. To judge such a crucial point, check whether there is any air entrapped in the plug cylinder. If there is air, we should judge that the epoxy resin is not properly filled in. Here, if we assume that the viscosity still lacks, then fill in additional Everbond EP300 of low viscosity type. Since the plug cylinder is clear, you can check the resin gradually filling inside. As the resin enters the pressure tank, the air inside the tank is compressed. By that pressure, the resin is gradually filling in a crack. When the resin is emptied in the pressure tank at any plug, add Everbond EP200. In this additional resin, increase the sacking volume more than the previous case of EP400 to the scale of 1 of the pressure tank. First, inject Everbond 400 in advance. At a spot where Everbond 400 has been exhausted, additionally inject Everbond EP300. Succeedingly, further inject Everbond EP200. Similar processes should be followed with EP150, then EP100, until there remains a slight residual resin in the pressure tank at the plug. Thus, the additional injections should be performed by using the epoxy resin of higher viscosity than the previous one. On the completion of the injection work, keep the unused epoxy resin on the site as a sample for checking the hardening condition. Thereafter, check the sample from each type of the Everbond. If the sample is in a proper hardening condition, we can judge the resin injected inside a crack will have hardened to the proper state. After checking the proper hardening, remove the temporary seals. Insert a screwdriver in between the temporary seal and the plug. Remove the plug like this. Also, the seal should be removed. Because this repair work involves the improvement in appearance, we will conclude the work with a simple improvement. As required for each crack spot, repair the crack trace with quick-drying polymer cement or other substitute to hide the unsightly spot. In this case, we use Sika's SK Osmotic Primer and Zyne SP Cationic Filler. Now, we have completed the repair in this appearance. We have completed all repair procedures for SK Grout Plug A method on exposed concrete surface.